Hello, and today we're going to learn how to manipulate log expressions, specifically expanding and combining them. So here's what we mean when we say expanding and combining. Expanding a log expression means rewriting the expression with one factor inside of each of the log functions. All right, so we're writing, several different log functions if we can. Condensing is doing the opposite. We're taking several log functions, and if we can, condensing them into the fewest amount of log functions we possibly can. So let's get started. All right, so here we have a log expression that's log of 2 times x to the 4th times y to the 5th. Recall from your laws of logs that if you have a product on the inside or in the argument of your log function, you can rewrite it as the sum of those factors. So we'd have log of 2 plus log of x to the 4th plus log of y to the 5th. And there we have it. We have expanded our log expression so that each factor in here has its own unique log function. Okay? All right, let's look at condensing. So here we have 2 different log functions in this expression. They both have the same base, which is important. We cannot combine them or condense them unless they do have the same base. So they have different coefficients, which is not good. We need to have it in the form of log of something minus log of something. That's what the rule states. That's what the law states. So we need to get rid of this coefficient here. We can do that by using that power rule and saying that log base 3 of x cubed minus log base 3 of y to the 5th. There we go. Now we can actually combine these log expressions together by using that quotient rule. So we have log base 3 of x cubed divided by y to the 5th. So that's what we take the log of. Real quick comment up here, x and y, they both have to be positive because they're both on the inside of the log function. So that is true throughout the entirety of this manipulation. On the inside here, in order to say that this is equal to this, it's only equal when our x and our y values are all positive. Alrighty. Let's talk about expanding this guy. It's a complex one because we have numerator and denominator made up of several factors each. So let's first start by using that quotient law to separate the numerator from the denominator. We have the natural log of 3z to the 7th is equal to, minus the natural log of x squared y to the 4th. Okay, to expand further, this has 2 factors in it. We can get each of these into their own log. So this would be natural log of 3 plus natural log of z to the 7th. Okay, over here we have a negative sign in front of this, so we can do the same thing, but we got to remember that this negative sign is going to apply to anything we do to this expression. So natural log of x squared plus natural log of y to the 4th is how we could expand this term, but because we're multiplying this whole term by -1, in the end, both of those pieces, we're going to have a -1 multiplied by them. So this is minus the natural log of x squared minus the natural log of y to the 4th. So we have expanded this, and because this had a negative sign in front of it, we had to distribute the negative sign. Alrighty, let's look one more time at condensing before I do one more tricky condensing problem. Here we have 3 things being subtracted. Okay, let's start off by taking this 3 and rewriting that as log of 2 minus log of x minus log of y cubed. Okay, well, we could just do this in order. So log of 2 minus log of x would be log of 2 divided by x minus log of y cubed. Okay, to subtract another log, I'm going to have to divide 2 over x by y cubed. If you divide a fraction, same thing as multiplying it by the reciprocal, so it's going to be multiplied by 1 over y cubed. So it's going to be 2x over xy cubed. There you go. Again, when we started off, our x and our y's had to be positive in order to satisfy the restriction on log, so down here they have to be positive as well. There's another way of doing this, so I'm going to take it from here, okay, and I'm going to show you another way. We can factor out that -1 from both of those, so we'd have log of 2 minus, factor out that -1, log of x plus log of y cubed This can be combined because this is a sum and it's inside parentheses. You always hit the stuff inside parentheses first. Thank you, order of operations. This would be log of xy cubed. And now if we subtract log of xy cubed from log of 2, well, this would just be log of 2 divided by xy cubed. So just another way of thinking about it. Same restrictions apply. All right, one last thing before I go. It's a little bit tricky. So we here have something asking us to condense log base 7 of x plus log base 3 of y. The tricky thing about this is that this cannot be condensed. Our bases are not the same. This has a base of 7, this has a base of 3. So the laws of logs do not apply, because if you recall, the laws of logs only worked when your bases were the same. So this is as condensed as we possibly can get. And that is how you manipulate logarithmic expressions.